What a pleasure it is to be here today on behalf of people with type 1 diabetes, which has been my professional focus and passion. So I want to just let me see if I can, excuse me, I want to make sure which, okay. Just to, excuse me, my disclosure slide is gone. Maybe my disclosure slide got dropped off. So I'm going to be talking about type 1 diabetes today, and again, this has been the focus of my career, and beta cell deficiency is really at the heart of type 1 diabetes. As you can see here, there's a profound deficiency in beta cells, and the pancreas of a person with type 1 diabetes is on the right. A shocking lack of insulin-producing cells in the pancreas. And it leaves people with type 1 diabetes in a very tough space. So I got interested in low carb and type 1 diabetes a while ago, and that's been a source of my passion. Okay, so the slide was out of order, but this is my disclosure. I'm a consultant for Sanofi and Lexicon and No Foods, and I'm now switched from academia to serve as medical director for McNair Interests, which is a private equity group with investments in areas related to type 1 diabetes and other chronic illnesses. So type 1 diabetes is a serious problem, and pediatricians like myself would often see patients like this. Up to 100 years ago, it was a devastating diagnosis. So these children would arrive emaciated, parents dreading the possibility that it could be diabetes, and they would unfortunately be told that there was nothing available. But with the discovery of insulin by Banting and Best, this really miraculous thing occurred where you could begin to inject and replace insulin for these people who live with type 1. And you'd see these incredible stories. This is the same child on the right as the one you see on the left. So it was remarkable and transformative. There were ticker tape parades for Banting and Best, who won the Nobel Prize. And at the time, it was considered a cure for type 1 diabetes. Unfortunately, we now know that insulin is a treatment. It's not a cure. And there's really a very significant burden that's borne by people who live with type 1. And in the years after the diagnosis after the discovery of insulin, people began to suffer from unforeseen complications. And this is a case series from the Joslin Clinic in the decades immediately following the discovery of insulin. And you can see these patients are suffering from all of the classic conditions that we now believe to be the complications of diabetes: calcified arteries, retinitis proliferans, high blood pressure, and proteinuria. So this is macro and microvascular disease manifesting in the vessels and in the kidney. And unfortunately, the insulin-treated type 1 diabetes patients had very high rates of mortality, even into the 90s. And this was devastating. So if you think about this, a large fraction of patients who were diagnosed with type 1 diabetes around the time that we put the man on the moon, those people would still have dramatically foreshortened lifespans. I was born in '65, so I'm 53. I don't have type 1 diabetes, but if I did, I would have been diagnosed somewhere around 73. So you can see that I would then, in my virtual diabetes, would be 45 years in. So let's look at the people who were 45 years into a diagnosis of type 1 diabetes, and you can see that at least a third would have expired by now, perhaps even 40%. Devastating. So this was really terrible, and an amazing thing happened, which was Dr. Joslin and others had been advocating for a proper controlled clinical trial to try to determine whether tight control could improve outcomes for people with type 1. And the answer, thankfully, is yes. So now what we live with is a different landscape of type 1 diabetes. We don't think that complications are a foregone conclusion, and we do everything we can to support people who live with type 1 diabetes. It's millions of people worldwide, 1.25 million Americans, at least, possibly double. We could talk about that at the break. Injected insulin is the only available therapy. There's a high burden of illness. It's very challenging to keep blood sugars in the normal range. There's risk of excessive weight gain and hypoglycemia with increased insulin. And frequent hypoglycemia, typically 1 to 2 episodes per week, but some people have a half a dozen. And there's a major risk of life-threatening complications, potentially preventable with tight control, as shown by the DCCT, the Diabetes Control Complication Trial. So it's a challenge for people like myself who support those who live with type 1, and it's a challenge for those who live with type 1 and their families. And definitive therapies, I guess what you would call cures, are a long ways off, and I want to try to explain why. There's been a big question: when will basic science knowledge translate to improve type 1 diabetes outcomes? And sadly, I'm here to tell you that it's a long and winding road. And I'm a physician scientist. I've been running a basic science research lab in beta cell biology and type 1 diabetes now for more than 15 years, and have been involved in the field for more than 20. And I think we're probably a long ways off from what you would think of as a cure. And there's a lot of different areas that people are investigating, including this idea of beta cell regeneration, finding some way to regrow the beta cells within the pancreas of people who live with type 1, or also stem cell therapy, and the idea of somehow finding some magic cell that could produce quite a bit of insulin that would replace the cells that are lost, or potentially also, I'm sorry, my pointer is non-responsive. I'm going to keep trying here. Oh, okay. Immunotherapies is another one, and advanced technologies. So immunotherapies has been popular, this idea of infusing various things that would modulate the immune system, either T cells or B cells or both, or Tregs. But thus far, all of those trials have failed their primary endpoint. So they're not able to permanently induce tolerance. They can only temporarily slow the destruction of the beta cells. And then finally, advanced technologies have been somewhat of a disappointment. We had imagined that you just strap this machine on somebody and infuse insulin in a regulated manner, but the sad truth is that it takes so long for what you eat to influence what your glucose is, to then influence what the machine senses, to then influence how much insulin to deliver, that it's sort of like driving a car that's like 100 feet long from the very back down a highway really fast. And you're making these sort of fishtailing changes, but you're not able to make those changes fast enough. And so what you see, even in people who are on automated insulin delivery, is quite a bit of glucose flux. Okay. Well, I've published on beta cell regeneration for most of my career. And about 10 years ago, we had preliminary findings in a paper that was ultimately published just last year that describes how beta cells persist in T1D pancreata without evidence for ongoing beta cell turnover and regeneration. I'm not going to show you that work here, except to say that for me, this observation precipitated what my wife calls a professional crisis. And I didn't buy a red sports car, and I didn't get a tattoo, but I really did worry about what I was doing in my career. And my fear was that my efforts to regrow beta cells might be unsuccessful, and I might never really know the impact of my work to advance humanity. And so I began thinking about myself more as a physician and less as a scientist, and I've spent quite a bit of time reorienting myself towards that. I would also say that stem cells in particular have proven to be a disappointment. And this is a commentary that we wrote in Cell Stem Cell about a paper that was published by Doug Melton and another one that was published by Tim Kiefer. And we're a long ways off from being able to take embryonic stem cells, turn them into bona fide insulin-secreting cells, and then safely put them into a human being and make sure that they don't get immediately destroyed and that they don't cause other metabolic problems. I would be surprised if this could be achieved in my lifetime. So what are we going to do? I don't know. I mean, traditionally, we're not doing that well. So this is data from the T1D exchange, and it shows you that most people with T1D fail to achieve glycemic targets. We'd like to get their A1Cs under 7 if they're adults. We'd like to get the A1Cs of kids under 7.5. And moreover, it's not getting better. It's getting worse. What? Yes, it's actually getting worse. So the data on the left is those who are enrolled in this cohort from 2010 to 2012. And the right, these blue bars, that's current data. So we're not making progress with whatever we're doing. And moreover, there's excess cardiovascular death in typically treated type 1. And I'm a relentlessly positive, optimistic person, almost to a fault. But I want to show you something scary. This is a New England Journal article that describes cohorts of people with type 1 diabetes, and it sort of slices them by hemoglobin A1C. And you can see that it's going from the top with A1Cs less than 6 to the bottom, greater than 9.7. And those who have A1Cs in between 7.9 and 8.7 have an increased hazard ratio for death of any cause of 3.11-fold the non-diabetic population. So there's a lot at stake here. We have to do more to support these people. And cardiovascular death apparently is 4.4, and you can see that it increases with A1C. And moreover, we know there's socioeconomic disparities, so some of the poorest people in the population are going to be at incredibly high risk for cardiovascular death. We've got to do something. Okay, so all right. I want to take you on a tour through glucose homeostasis to talk about the role of the beta cell and why carbohydrates are really so important in type 1. So the islet, as you can see, the big round structure, and it makes insulin, of course, which acts upon the skeletal muscle to drive glucose into skeletal muscle, and it also acts upon the liver to suppress hepatic gluconeogenesis. And it also acts upon the fat, ultimately driving fatty acids in to promote adipogenesis. So this pathway gets really altered in type 1 diabetes. And part of the reason is you have very little endogenous production of insulin, and you try to replace it with exogenous insulin, and it's incredibly crude, whether it's a pump or a pen in this case. You just can't figure out how much insulin to give, and you're making a guess. And so if you take food, say for instance Snackwell's devil food cookie cakes, which are fat-free, and you can and you get a big bolus of carbohydrate, then all of a sudden you need a whole bunch of insulin to drive that carbohydrate into the skeletal muscle. But the same is also true in liver, and you get a whole bunch of insulin action upon the liver, and the same is also true in fat. And you're going to promote quite a bit of adipogenesis, and ultimately these folks end up quite overweight. And so we know that tight control is associated with obesity in type 1 diabetes, and that's associated with adverse cardiovascular outcomes in people with type 1 diabetes. So we get a problem because we're not able to physiologically replace this key hormone that's necessary for life. I'm showing you this. This is a table that was handed out at one children's hospital, and it's identical to the kinds of tables that are handed out throughout the country to parents of newly diagnosed children with type 1 diabetes. And so in this case, imagine yourself the parent of a teenage boy who's just been diagnosed with type 1 diabetes, and you have a well-meaning nutritionist who explains that your child needs 2,300 kcals per day, and for breakfast should consume 75 grams of carbohydrates, 105 for lunch, a 15-gram carbohydrate snack, and a 120-gram carbohydrate dinner, and a 15-gram snack at bedtime. So what does that do? What's that like? Unfortunately, it's incredibly difficult to do. And the reason is you don't really know the number of carbohydrates, nor do you know the transit time in the gut or the impact of the fats that you're consuming, and you end up making this random guess, as they call us. Like it's a wild guess, and it's probably plus or minus 50 or 100%. So you're like, I don't know. And people with type 1 diabetes are classic for saying, you know what, I had no idea. I guessed 50 or I guessed 25, because you can't walk around with a gram scale, right? And I know people who have done this. My friend Kelly would go into restaurants with a measuring cup in her purse when she was pregnant and she was trying to achieve euglycemia. But even that isn't good enough. And even a gram scale and measuring cups is not enough. So you'll see glucoses that will rise and fall throughout the day. This is data from a continuous glucose monitor. This is a Dexcom readout. And you can see the average glucose of this person is 204, but the standard deviation is 90. And there's also a psychological impact. So imagine yourself on this roller coaster going down, and you don't know, this is in the middle of the afternoon, you don't know if you're going to end up with a blood glucose of 100 or 50 or 30. And it's terrifying, and it causes really, it's a huge cognitive load. It's a burden to have to think about because you're never quite sure what your sugars are. Okay, so I've gotten interested in low carb mostly out of desperation. And as a physician, my thought was I had to find something different. And so I started thinking about this, and I started asking questions. And what I realized was that many people didn't know answers. So I asked, why do we even prescribe a lot of carbohydrates? And I found the Standards of Medical Care in Diabetes, and what it basically says is, well, there's limited research concerning the amount of fat for individuals with diabetes, but the Institute of Medicine has defined an acceptable macronutrient distribution range of total fat as 20 to 35%. And I thought, well, what is that? What is that advice? And so I was curious about this and actually went and tried to understand this. I'm trying to advance slides. Oh, and by the way, this advice is still here, and it hasn't gone away. So this is the American Diabetes Association, and we're still prescribing quite a bit of a macronutrient distribution that includes quite a few carbs and not that much fat. So the DRI is published by the Institute of Medicine back in 2002. And this is really where a lot of the dogma around carbohydrate balance comes from. And I want to take you through some of the logic that's present within it. It's about 350 pages. It's remarkably lucid. It has a tremendous amount in it. It's written by some very smart people. And it describes how there's a huge amount of plasticity in our bodies to adapt to different macronutrients. But unfortunately, the DRI has at the end of it lookup tables. And so everybody says, I don't have time to read it. It's 350 pages. Just tell me what it says. So they go to the lookup tables. So the lookup tables were designed essentially as a compromise around something that, and I believe the lookup tables never should have been issued. And I want to tell you why. So what they say is that you have to have this acceptable macronutrient distribution range. And what they're saying is that if you get too many carbs, you're going to have low HDL, you're going to have high triglycerides, you're going to have more LDL particles, you're going to have increased cardiovascular risk, and so that's bad. On the other hand, they say if you eat too much fat, well, you're going to have more dietary energy, you're going to gain weight, you're going to have more saturated fat, and therefore you will have increased cardiovascular risk. And so they're thinking that these two extremes are each associated with cardiovascular risk. And so their logic is they try to find a balance in between the two. Based on the apparent risk for coronary heart disease that may occur on a low diet, and based on the risk of increased energy intake and therefore obesity and the consumption of high-fat diets, the AMDR of fat and carbohydrate is estimated to be 20 to 35 and 45 to 65% of energy, respectively. So they prescribed this, and this is why we eat what we eat. But it's based on false logic, and part of it is this idea that as you eat more fat, you will gain more weight. That is true in rodents who also consume a lot of carbohydrate, the so-called high-fat chow, but it's most certainly not true in man. So do dietary fats influence health? I read this amazing paper that Dr. Menti just mentioned, and I just thought it was wonderful, and I was blown away by it. And I began to read more and more things in the field, really shocked to discover that saturated fat was not associated with increased death. And moreover, that if anything, so trans fats might be, but interestingly, it's really industrial trans fats that are associated with cardiac disease. And ultimately, ruminant trans fats seem to be neutral, or at least not a strong signal. And amazingly, type 2 diabetes, these ruminant trans fats were protective. So that made me think that the evidence around saturated fat really needed to be re-examined for people with diabetes. And so are there innovative dietary interventions? Yeah. Dr. Richard Bernstein has been a pioneer in this field, and he's really an amazing person. And he's still in it. He's still involved in the field. He's active, and he has type 1 diabetes himself, and he's written this book that describes a wonderful approach to living with diabetes, and it's gaining more and more attention. So I know people who have followed it. In the field of pediatric endocrinology, this book is not at all taught. It's considered to be a scary, dangerous thing. And I only learned about it through my friend Kelly, who has type 1 diabetes herself, and she was trying to find an innovative approach to achieve euglycemia. And once I read it, I was hooked. So what do you actually do if you're doing this? Well, this is a picture of my friend Marshall and his standard poodles you can see down there on his feet. And we were having lunch, this is last month, and he's eating smoked salmon and some avocado and some aioli that he made himself and some low-carb bread. And that's a very typical lunch for him. He has type 1 diabetes. He's had it for nearly 30 years. And his blood sugars are quite good. As you can see here, this is postprandial by about an hour. His blood sugar was 87, which is awesome. And he took very little insulin. When I talked to Marshall about type 1 diabetes and low carb, we've sort of been working together. He's a close friend. He's the son of one of my oldest, closest friends. After he started playing with low carb, he said to me something amazing. He said, I always figured that I was going to die from type 1 diabetes. And when I learned about low carb and learned how powerful it was, I actually realized that I might be able to live a normal life. And that's pretty amazing. And it changed the way I think about working with people with type 1. So I showed you this CGM tracing. This is an 18-year-old patient who's had type 1 diabetes for more than 10 years. This is a high-carb day. And this is the same person now on low carb. So it's really amazing. And you can see that there's very little glucose flux. So she's able to cruise throughout the day with no fear of hypoglycemia and a lot less effort. Here's a 23-year-old with type 1 diabetes for 12 years on a high-carb day. And again, these huge roller coasters, quite scary, with a couple episodes below normal, and a low-carb day. So really dramatic. And here's a 22-year-old who's only had type 1 diabetes for a year, low carb since diagnosis, basically flat blood sugars. And it makes you wonder whether immediately going on low carb might allow you to preserve beta cell function. And I don't know the answer. We have to try to figure this out. So how about low carb and automated insulin delivery? And I want to tell you about a guy named Adrian LXM, and he is a developer for a do-it-yourself automated pancreas system that works through the Android phone. And that's called Android APS. And so these folks are hacking their phones to operate their insulin pumps to use continuous glucose monitoring data. And here's his glucose tracing. This is over, as you can see, the time scale is completely different here. So this is several days. And you can see on a high carb day, there's quite a bit of flux. And on low carb, almost none. So I actually think that automated insulin delivery will wildly synergize with low carb. And part of it is that it's much closer to the kinetics. You get roller coasters with low carb, but they're slower roller coasters, and they're the kinds of roller coasters that might easily be matched by the kinetics of computer-controlled exogenous insulin. But time will tell. We need to do these experiments. So there is this wonderful paper that's just come out, and this is in pediatrics, and includes, by the way, Dr. Sarah Hallberg, who's going to come right after me, and a bunch of other folks here. And so what is this paper? This is a description of a cohort of a Facebook group of people who are followers of Dr. Richard Bernstein. And they were able to achieve a hemoglobin A1C average of 5.67%, which, according to pediatric endocrinologists like myself, is impossible. We just don't see it. And moreover, they were generally happy and healthy and very enthusiastic about what they had done and what their lives were like. It's called Type 1 Grit. It's on Facebook. It's quite a neat thing. Okay. The New York Times wrote about this, and there was a lot of excitement. I love this. I do this so that I can be healthy, Andrew, who lives with his parents in Jacksonville, Florida, said. When I eventually move out and go to college, I'm going to keep it up because I know I'm on the right path. Now, that's pretty exciting. There was a comment from 3 major players in the field, Beth Meyer Davis, Lori LaFell, and John Buse. And they wrote a comment basically saying that although it may be true that very low-carb diets can be useful, we find the study to fall well short of this level of scientific evidence that merits the media and professional attention it seems to have garnered. The online community was not a general type 1 diabetes community. Rather, this is a community following a specific type of low carb as promoted by the author's type 1 book. And there's a general concern here that the individuals in the cohort believe in the approach, and therefore that would bias the outcome. So it's really and that promulgating such methodologically weak, although enticing data broadly through the media creates a risk that patients or providers may pursue such plans without adequate insulin adjustment, resulting in serious issues for hypoglycemia as well as risk of nutritional deficiencies. So this is the kind of stigma that low carb will have to overcome over time to ultimately advance. Okay, so Ludwig et al. Wrote a very nice thing, and they basically said, we don't think the suppression of information is a good idea. Low-carb treatment was used before the discovery of insulin, and we would love to ultimately see studies. So would low-carb violate nutrition consensus guidelines? Well, the answer is yes, clearly. And so so this is the ISPAD guidelines. This is the International Society of Pediatric and Adolescent Diabetes, and they are crystal clear that it would, at least according to their dogma. And they say there is international agreement that carbohydrate should not be restricted in children and adolescents with type 1 diabetes, as it may result in deleterious effects on growth. So I'm not sure about this. It seems hyperbolic, but they're very strong that it would. On the other hand, and they say healthy grains, et cetera. If you look at the American Diabetes Association, it's far easier. I'm going to skip this stuff. The American Diabetes Association has basically backed off quite a bit, and they have this lovely statement. Studies examining the ideal amount of carbohydrate intake for people with diabetes are inconclusive, and the amount of dietary fat is controversial. So that leaves some wiggle room for us. And my hope is that over time, we will begin to carry out some proper studies. But again, they don't seem to be precise in saying that you have to eat a certain number of carbohydrates. They say it's inconclusive, and Mediterranean food might be helpful. So I think, again, there's a lot of wiggle room in the American Diabetes Association. It's not as prescriptive as it used to be. There's room for experimentation. Let's see. Let's do the experiments and let's find out. They're a lot less dogmatic than they used to be. They say it should be individualized. My hope is that we can individualize and determine the impact. So I'm going to skip this. Some resources. Well, I mentioned Dr. Bernstein's book. And I would also mention this terrific book by Adam Brown called Bright Spots and Landmines. And then I want to just briefly talk about the potential impact for low carb and type 1 on disease burden and control, acute complications, growth and development, synergy with automated insulin delivery, specific low carb strategies, and lipid and cholesterol, cardiovascular metabolism, and all these other factors. And when we design clinical trials, and they will eventually happen, I promise you, in my lifetime, there will be clinical trials testing these things with the stuff on the top as the primary outcome and the other ones as secondary outcomes. And we'll do this in lots of different populations of people, and we'll be able to measure the impact of low carb relative to some of these other therapies. Okay, so why so little knowledge? Well, this is tough, and I think there's unrealistic timelines for the cure, and there's also communication barriers in between adults who live with type 1 and key stakeholders, i.e. maybe parents of young children. There's not a lot of communication back and forth. There's lack of T1D nutrition research funding, and there's incorrect assumptions. And my favorite is the one, people with type 1 diabetes need the best nutrition for the general population and must follow IOM AMDRs. So, where do we go from here? Ultimately, it's about building a consensus and trying to advance science. So how do we do this? Low carb research funding. We have to have more funding and better studies. We have to advocate for better nutrition standards. Please support the Nutrition Coalition. We need to recruit adult T1D peers to serve as volunteers in diabetes clinics. That we need to foster psychology collaborations to test the impact of nutrition on mental health. We need to increase access to continuous glucose monitors and ketone testing. They're going to be essential. And then ultimately, advocacy, mentoring, stewardship, and local reinforcement. And I'm going to close with a picture of some friends of mine. We had a potluck, and this is a low-carb type 1 diabetes potluck in Houston. And it was followers of the Type 1 Grit Facebook community, and we were there to support each other, share recipes, and just have fun. And I think it's going to require building community to advance this and ultimately serve the whole population of people with Type 1. So thanks so much.
Thank you very much. We're going to have a 20-minute break and reconvene to hear Dr. Sarah Halbert.